안녕하세요 여러분. 오늘 우리는 확률 통계 중에서 연속 확률 변수에 대한 평균, 분산 등등에 대한 이야기를 해보려고 합니다. 먼저 확률 변수란 개념에 대해서 살펴보고 확률 변수가 어떻게 분류가 되고 우리가 관련된 개념 그리고 이를 이용해서 우리가 어떤 문제를 풀 수 있는지 등등에 대해서 공부를 할 예정입니다. Today we will study random variables. You have already studied discrete random variables in mathematics 2, and in this semester you will study with a focus on continuous random variable. So we will start with the definition of random variable, and we can classify random variables as discrete ones and continuous ones. For example, binomial distribution is a discrete random variable, and a normal distribution is a continuous random variable. Usually, a discrete random variable can be represented by using PMF, which is an abbreviation for probability mass function. Or we can also use some table to represent a discrete random variable. In the case of a continuous random variable, we can represent it as a probability density function or graph. So in mathematics, representation is very important, and so you should be careful in studying various kinds of representation. And then we will study what is probability, what is mean, and what is variance. So basically, probability theory was developed to expect what happens in future. So in probability theory or statistics, our main focus lies on expecting mean, and to expect mean, we want to use some tools like probability or variance. To calculate probability, we use probability mass function in the case of discrete random variable, and we also use a probability density function for continuous random variable. And cumulative distribution function is defined for discrete one and continuous one. Then for these two cases, we will study how to calculate expected value, and then we will also study what is variance and how to calculate variance. And then from a given random variable, we can generate a new random variable by using plus minus multiplication and division, but it's not so easy for us to study some random variables generated from old ones. So we will not study much about these generators. And as application, we will study how to calculate probability in some normal distribution. After studying this chapter, you will see how to calculate your length if you see the expected value and variance. So this is the structure of this chapter, and from now on we will study step by step from definition to application. Okay, so let's start with definition. Random variable is a concept combined with the probability and variable. So this is denoted just by writing IV, and this is a concept of random is related with the probability, and so we can consider it as something related with the probability and variable. For example, if you toss a coin, then you can count the number of landing heads. So the number of landing heads can be any number between 0 and 10. So it is a variable, and you can easily expect that if you toss a coin 10 times, then the probability that the it lands head 5 times is more probable than the probability than the event that it lands 0 times in head. So random variable is a variable which is related with some probability, and we can classify random variable as discrete one and continuous one. So if x is a random variable and the number of values that x can take is finite, then it is said to be discrete. Or sometimes it can take infinitely many values. And in this case, x is said to be discrete. And if x takes if x is not discrete, then x is said to be continuous. You know what is a continuous function. You have studied in the previous semester what is a continuous function, but the continuity in the random variable is a little bit different from the continuity in limit theory. Okay. So you may consider many examples for discrete random variable. For example, if you toss a coin and if you count the number of landing heads, then it is a discrete random variable. And you may think it is not so easy to find some continuous random variable, but you can consider x to be the time that you can get up tomorrow. Then it can be any time. So it can take infinitely many values if x is case x is discrete random variable. x is if you consider the time that somebody wakes up, then I will usually take a value between 5 and 10. So usually a man or a woman wake up from 5 o'clock to 10 o'clock, but somebody may not wake up in this o'clock, but here are infinitely many values. Okay? Comfortably. In this case, it is uncomfortable. So here, comfortable means mathematically a set is said to be comfortable if there exists one-to-one correspondence the set of natural numbers. So, for example, the set of rational numbers is a countable set, but the set of real numbers is not a countable set. So we have studied what is random variable and what is discrete random variable and what is continuous random variable. I think you have already studied binomial random variable, and you must have studied how to calculate probability, expected value, and variance for binomial random variable in mathematics too. And later we will study what is a normal distribution, and in the case of normal distribution, it is completely determined from mean and variance, and we will study about probability. And so for each case, that if x is random, discrete random variable or continuous random variable, we will study how to calculate probability, mean, and variance. To express probability, we use some tools called probability mass function or probability density function. And we will study what is a cumulative distribution function, and then we will study PNF and PDF. If x is a random variable, and then we can define large F whose domain is x and whose codomain is the closed interval 0, 1, and it is defined by this rule, that means the probability that the random variable large x is less than or equal to x. Sometimes this is expressed as this one. But in Korean mathematical book, we use this notation, but in some textbook, we use notation like this one. And the function large f, which is completely determined by the probability, is called cumulative distribution function. Or simply, it is denoted by CDF. And in the top, if you see the first page, you can find some properties of probability. And so you can easily understand that, for example, and calculate this one as f d minus f of I, because this is equal to the probability that large x is less than or equal to b minus x is less than or equal to a. And so we have such a kind of equation for probability. And then we'll recall what is probability math function and how to calculate probability in the case of discrete random variable. So usually we express discrete random variable by using some table. So in the case of discrete random variable, PA means, this means the definition. The probability that the random variable large x takes value A is denoted by P of A, and this function is called probability mass function. Actually, small p can be considered as function from large R, the set of real numbers to the cross-stage word 0, 1, and this is called the probability mass function. Then you can see that if x takes values, say from x1, x2, and so on, then if is PMF and probability mass function is denoted by using the notation PMF. then you can see that x is always greater than or equal to 2, and pxi is positive, and px is 0 if x is not equal to 1 and so on. And you can also see that summation of pxy should be equal to 1, and large